Now everyone know about the velocity, acceleration, right? Okay. So you two are new, right? Okay. So what is acceleration? Very good. And what is the what is the unit of weight? Newton. Very good. Fantastic. So okay. Do you know the equation of kinematics? No? So yeah, that's what
So,
we discussed in the previous classes. So basically we discussed the dimensions. We are starting from the 11th basics. So in rapidly we are covering the basics and then we will go to the 12th. So we discussed about the different dimensions. So I believe if you know the dimension of weight, then I know you know the other dimensions as well, right? Okay. So dimensions, and then we discussed about the straight line motion. For example, the acceleration, velocity, displacement, distance. You know the difference between distance and displacement? What is that? Okay, displacement is the shortest difference, right? Okay, that's good. Okay, and can you tell me the unit of acceleration? Very good. That's good. So, okay. What's your name? Both? Tejas. Okay. Yours? Rajat. Okay, that's good. So, you are studying here in the school? Okay, that's good. So, yeah, that's what we discussed in the previous classes. And today we will discuss the Newton's laws. So, can you tell me what is the first law of Newton? Yeah, very good. What is the second law? Ex- Exactly. Yeah, very good. So instead of saying F is equal to ma, this is the proper definition, right? F is equal to dp by dt. That is the exact definition. And from that definition, we get F is equal to ma if mass is constant, right? Okay. So if I say F is equal to dp by dt, so can you derive from this F is equal to ma equation? How will you do that? P is equal to ma. Very good. Then yeah, so it will come outside, right? Yeah. What if I say that mass is not constant? Then no. Okay, let me tell you. Then you have to differentiate, like then it means the mass is also a variable and velocity is also variable. Both are changing with respect to time. It means that you have to differentiate a quantity which is a multiplication, right? M and V both are in multiplication and you have to differentiate that. So you need the formula for that, right? So let me give you the formula. If you want to differentiate a multiplication of function AB, then what you will do, take A outside, so consider it as a constant and take the derivative of B, and then take the B outside and take the derivative with respect to take the derivative of A with respect to, right? Got it? Very good. So that is how we will do. So now you can differentiate MV, right? So what will be that? M dV by dt VD. Exactly. So if in a problem or in a question or in a scenario, it is said that mass is not constant, then we will apply this equation, right? F is equal to dp by dt, then we will write P is equal to mv, then this equation. Got it? Okay, that's good. You understood this part? The last part? This is the formula, AB. So just differentiate the multiplication of A and B, right? This is the formula. This is very important formula, so need to remember it. So that is the second law of Newton. It is very important. It is also called equation of motion. F is equal to dp vector divided by dt is also called as equation of motion. And if I say that mass is constant, then F is equal to ma is the equation of motion. Got it? Now, why is the second law very important? I will tell you. Second law means dp by dt or ma. So when, like, if we want to solve the dynamics of the particle, it means if we want to find out, okay, let me tell you this first. Do you know what is the condition to apply the kinematics equation? Okay, and no, like if we want to use kinematics equation, so is there any condition for that? A should be constant, right? Acceleration should be constant. Then only we can apply kinematics equation. Kinematics equation means v is equal to u plus at and those three equations, right? So always write a note that we can only apply the kinematics equations if acceleration is constant. Okay. So now, like now, now if I give you some question, like if some object is falling toward the ground, okay, and initial velocity was 0, then find out its velocity after the height h. So in order to, like, in this case, acceleration is constant or not? Constant, because a is equal to g, right? So you can apply those three kinematics equation and can solve this, okay? And you can find out the final velocity. And you can also find out the s also, the displacement, right? So this is fine, because if you know these three equations, you can find out the final velocity and all if acceleration is constant. Now you might ask me the question that what if acceleration is not constant? What if acceleration is not constant? Then how would we find out the final velocity or any other quantity like displacement? So do you have any answer? So that answer is the second law of Newton. That is why it is called equation of motion. Because if we want to understand the motion of the particle, it means if we want to understand the displacement, velocity, then we always use second law of Newton. F is equal to ma. Okay. Okay. So F is equal to ma is always valid. Even in non-uniform acceleration, even in uniform acceleration, always. This F is F external. It means the external force. You know what is external force? The force applied on the object by external agencies, right? For example, the force applied on Earth is what? What is the any force on this Earth? Gravitational force by the, yeah, gravitational force by applied by sun, moon, right? Okay. Now you can see like there are some internal forces also inside the Earth, like there are molecules, right? So they will be attracting each other, but we are not considering these forces. because they are internal force. We need the external force only, which is acting on the whole object, right? Got it? Okay. So that is the F external force in this definition. Now I will explain you the meaning of this equation. So meaning of this equation is this, that if there is some, okay, let me tell you first, what is required in order to have the acceleration, in order to change the velocity? Force is required, right? Like, yeah, from this equation you can say m dv by dt, right? F is equal to dp by dt. So it is m dv by dt. So if you want to change the velocity, then you need the external force. If you will put F external equal to 0, then your velocity will become constant. If F is 0, then velocity will become constant because dv by dt is 0, right? dv by dt is 0, it means velocity is not changing with respect to time. These are some basic things that you need to know, right? So it means that if force is 0, then velocity will remain same, as you said in the first law of Newton. So what is required in order to change the velocity? Force, right? Non-zero force. So that's what is saying in this equation, that whatever force we have, whatever force on the object we have, we will write it in the left hand side. That is the force on the object. Now in the right hand side, we will write m into a vector. It means the acceleration due to that force. Because if there is a force, then there is an acceleration. So that's the meaning of this equation, that if there is a force, then there is a corresponding acceleration. Okay. So this equation is telling us that how, like how much the momentum is changing or how the velocity is changing by some force. The force is an input, okay? Force is an input and output is the change in the velocity or acceleration. That's what it is. Okay. So this is about, this is the second law. Now what is the third law? Yeah, very good. So can you give any example of action and reaction? Yeah, very good. So what is action and what is reaction? Action is the thrust and reaction is the, very good. That's good. So because in a rocket, what happens is the fuel is burnt, so there is a thrust downside, right? There is a momentum downside. So that is the action. And due to that action, there will be a reaction force, right? In the opposite direction, because equal and opposite reaction. So the reaction force will be upside. So that rocket can go upside. So that is the only force that can work in the space, because if you are in a very deep space, like, you know, there is nothing, there is no gravity, then how, like you are moving with a constant velocity, so how can you increase your velocity? There is no chance, like there is no wall or something, so you can increase your velocity. So that is your only option. Apply some, in the backside, apply some thrust, so you will get this velocity. That is how these missiles and these satellites gets their velocity, by applying some force downside. Even if you will, like, you know, you have a ball of some sand and you are in space, if you will throw that in backside, so you will accelerate in the front side. So that's how you can approach a speed. Okay, that's good. And what are other examples? Some simple examples. Bullet fire, the gun will recoil. Okay, good. Kicking a ball. Okay, of course. Then what is action and reaction in that? What is reaction force? You are no. Are you saying that we will apply the force on the ball? So that is action, and then the ball is moving in the front side. That is reaction. No. See, if action is working in this, action means the action force. Yeah, because you know when we kick the ball, then we apply some force, but we also feel some pain, right? Like because that is football. That's why we feel very less pain. Have a ball of concrete. Have a ball of concrete and then kick it. So you will apply the force, and then that concrete will also apply the force. So it will pain in our leg, right? So that is the reaction of the concrete. Or either kick the wall. With this punch, kick the wall, you will apply the force, and the backward force will act on your punch. So it will pain in your hand, right? And there is one example. If you are throwing a ball like that, then it is coming back, right? Because the ball is applying a force on the wall, and the ball is also applying the same force on the ball. That is the example. Gravitational force is also an example. Like the moon is applying the gravitational force on Earth, and Earth is also applying the gravitational force on moon, right? The force is in the both of sides. Even when you are also applying the same force as Earth is applying on you. So then you will say that, sir, then why I always, when I jump, then I come to the Earth. Why Earth cannot come to me, right? No, force is equal and opposite. Like I'm saying there is equal and opposite force, right? So if Earth is applying, like, just say that this is the Earth and this is this person. So this Earth is applying the gravitational force on this person. This person is applying the same force on the Earth. That is why it is equal and opposite. It means in the opposite direction, but the magnitude is equal. But now, now you might ask that then why this person come to the Earth? Why doesn't this Earth move to the person? Obviously, you will continue to apply force. That is why you are coming downside, because Earth is applying force now. You will also be keep applying the force. Like if there is action, there will be equal and opposite reaction. If the action will remain for 5 hours, the reaction will also remain for the 5 hours. Then action and reaction are not equal, right? No. Like what you understand by action? Action is the action force. It means the force you are applying. That is what we mean by action. Action is not something like if I am moving in that direction with velocity v, then I will be moving in the opposite direction with velocity. No. Action means action force only. It means if we will apply some force, then there will be equal and opposite force. Just that. So what I'm saying is this person is at the height edge. This Earth is applying some force, right? So this person is also applying the same and opposite force. This can be given by Gm, capital M, divided by R square. This is the force between these two objects, right? So Earth is applying the force, object is also applying the force. Then why this Earth is not moving? You tell me that. That's good. And after that? Yeah, so? Yeah, but your answer is 70% correct. Your answer is correct, but a little bit of problem is there. Reasoning. in the gravitational force there is a multiplication of masses. So it doesn't matter, like, if it is G capital M into M or G M into capital M, right? The force is equal and opposite. Force is not different. Okay, let me give you. Are you curious to know this answer? Are you really? Okay. I said now F is equal to MA is very important. That's how you will get the answer. A is equal to F by M. I said that force is there, but what is the result of the force? Like, we are falling to the ground. That is the result of the force, right? What is the result of the force? That's what we want to know, right? So, yeah, let me write it out. So this is the force on us. Okay, this is the force on us. So you can say this is the force on person, that person. So what is this mass of person, right? And what is this acceleration of person's acceleration, right? Acceleration of person. It means what is the acceleration of that person, like how the speed of that person is changing with respect to time. That is it, right? So force on person will lead the acceleration of the person, right? If the force is acting on me, then I will accelerate, right? So that's the equation. You need to know this thing. Now this acceleration of person will be equal to the force on the person divided by the mass of the person. This is the one thing. Now if I write the same equation for Earth, then it will be acceleration of Earth is equal to the force on Earth equal to the mass of Earth. The same equation I have written, right? Because Fe and Fp are same, right? Because forces are equal and opposite, so same. So you can say that it can also be written as Fp divided by Me. So now this MP is very small quantity. It's very small, right? Compared to the mass of the Earth. The mass of the person is very small. So acceleration will be no. See, the MP is in the denominator, right? So if MP is in denominator, so MP is very small, then what will be the acceleration? Higher, because it is in the inverse proportional relation. Like this inverse proportional relation. Okay. So if you divide some quantity by some smaller quantity, the other quantity will get bigger, right? Like if you divide 2 by 1 by 2, then it will become 4. That is why. Okay. So acceleration of P is very higher. That is why we accelerate to the Earth. Then why doesn't this Earth accelerate to us? That's the reason. Mass of the Earth is very high compared to this our mass or the force. So mass of the Earth is that much high that the acceleration of Earth is very less. Because if mass of Earth is very high, then acceleration will be very less. It is that much less that we cannot even observe. Like if acceleration is something 0.0000000000001, then will we able to observe it? No, we won't see any acceleration. So that's the case. Got it? Got this concept? So now I understood the meaning of second law and action and reaction also. Now the third law seems very easy, but it is not, right? The definition is easy. It is also easy. It's not hard, but just it's about the concept. It's not hard. So now there is one more example of this action and reaction. This person is standing on the ground. So what is the force acting on this person? Gravitational force. What is that equal to? Mg, right? Mg. M is the mass and A is G, right? Mg. Now, this is the force applied on the person by the earth. Now, what is the reaction of it? This is the action force, right? Now, what will be the equal and opposite reaction? Normal force. Very good. Normal reaction. That's good. So, normal force. What is normal force? Acting upwards. Right? That is why we do not move downside even there is a force. We are just standing on the ground because there is an equal and opposite force on us. That is normal force. And we are also feeling that force because when we are standing on the ground, we feel our weight. No? We feel our weight. For example, if a person is having 50 kg of weight in his hand, so he's feeling his weight because of this normal force, because the same amount of normal force is applied. Okay, that's good. So for this person, can you write the equation of motion now? F is equal to ma. F will be the net force on this person. So how will you write out the net force for? You can assume any direction as positive direction because we always need Cartesian coordinate system. Always remember, if you start solving a problem, you will need Cartesian coordinate system, right? Which direction is positive, which is negative. So assume that this upward direction is positive. You can consider any direction as positive, but then you have to stick with it. So upward direction is positive. So what is the net force now? The net force is 0. Very good. But how will you write it? Mg minus n, right? But if the upward direction is positive, then yes, because n is positive now and mg is working downside. So if upside is positive, then downside is negative, right? Just like this side is positive x, so this side is negative x. So n minus mg is equal to m into acceleration is 0, right? For this person, acceleration is 0. This is not going downside or upside. So n minus mg is equal to 0. It means n is equal to mg. Equal and opposite force. They are both equal in the magnitude, you can see, and they are both opposite in the direction. Got it? Okay. Now, can you write out the equation of motion of this object M? Tension is equal to mg, right? Okay. Because tension is working upward and mg is working downside. And acceleration is 0. So T minus mg equal to 0. First we will write ma. Then acceleration is 0. It means T minus mg is equal to 0. It means T is equal to mg. This is very important. These things that I am doing right now are very important because you will be solving question using these things, just these things. I will be using equation of motion even in this 11th class, whole 11th class. When we will be studying gravitation, then I will be using it. When we will be studying 12th class and the electromagnetism, then I will use it. So better you should know this at this time, so you won't face problem later understanding the concept, right? So this is very basic and very important. Okay. So this is the concept of equation of motion. We write the net forces in there at that side, and then there is a ma. So we can even find out the acceleration also if we know the forces. So for example, if there is a this block, there is a 5 Newton force in this direction, 4 Newton force in this direction. Find out the acceleration. Mass is 5 kilo. Fine. 0.25. Okay. Find out 0.2. Okay. Yeah. Find out pound. Use the same thing. Consider this direction as positive direction. So 5 Newton is positive, right? Because it is in the positive direction. Then 4 Newton is in the negative direction because it is in negative direction. That is why it is negative. Then 5 kilo is mass and A, MA, right? So A will be 5 minus 4 divided by 5. So 1 divided by 5. Right? So your answer is correct. 0.2. 1 by 5 for 0.20. Okay. So these are very simple cases, just to understand. Now this is the question. Find out the acceleration A in the blocks. This is A block, this is B block. Find out the acceleration. Solve this question using the concept. We have taken only 2 classes, and most of the thing was about the dimensional analysis and uh, straight line motion. So basically, like it was very basic, like the dimension of force and dimension of weight. And then we discussed some very fundamental these definitions like the displacement, force, okay, and acceleration. So this is what we have covered by now. If you have any difficulties knowing them, you can tell me. I can repeat those things very rapidly. You can also revise the previous class second and third chapter. So they are very easy. Second is dimensional chapter and third is the straight line motion. Very easy. If you feel any difficulty, you can ask me. Yeah, it's third class. Approximately. I don't remember exactly, but it might be third. But that's what we discussed. Only basic things. Very basic. Okay. You calculated? Uh-huh. The answer is in ratio. What is that? 5 divided by 6. Okay. No. No. At this particular instant, what is the acceleration? Not getting? Find out the acceleration. Anyone? The same things you need to use. Okay, let me give some hints. Then you might be able to find out. Okay, draw it here. Yeah. So, because this is only a single string, right? A single string is going over there. So if there is a single string, then tension will be same in both of the side, right? And acceleration will also be the same, because if some object is going upside with that acceleration, then that string that is attached, that is not like elastic, so it can expand. If that object is going with some acceleration a, then it will also come with the same acceleration, because they are attached with the string. So now try to find out. The tension and acceleration are same in both of the blocks. Point 0.83. Someone is saying acceleration is 1. Okay, we will see that. You need to, because there are two blocks, right? There are two masses, so you have to apply two equation of motions on block A, on block B. 9.8, very good. That's correct. G. Now there is a weight working downside, right? So that is 6G, right? Mg, so M is 6. Here also there is a weight working downside, 5G. Now because this block is like coming downside, so there is a tension also, right? Upside. Here also the same tension, because the string is same, so the tension will also be the same. Now assume that this is, it's not assumption, we are just saying that if this block is coming downside with acceleration a, then this block will be going upside with acceleration a, right? Obviously, because it is heavier, so if it is coming downside, then that will come upside. Okay. Now write the equation of motion on a block. Equation of motion. Okay. So consider the positive and negative direction, which you have to stick with it. So consider this as a positive direction and this as a negative direction. Because in y coordinate we are writing, right? Okay. So equation of motion for this block will be t minus mg, right? Because t is positive because it is upside and mg is downside. So net force is t minus 6g equal to ma, right? And m is 6, a is acceleration. Now on B block, for the B block you can say tension minus 5g is equal to 5a. The same thing. This time the mg and 5a. So this is one equation and this is equation 2. Now there are two variables, tension and acceleration, and there are two equations. So You can solve that. If there are two variables and two equations, so you can solve it. So where did you make the mistake? Where did you make the mistake? Subtract the second equation from first. So t will get cancelled out. 6g minus 5g, 1g, 6a minus 5a. Right? Hmm? Yeah, that you can see. Okay, a is equal to g. So g is working downside. No, a will be equal to g, not minus. You can see in both of the ways, because you already considered upside direction as positive and downside is negative, right? Yeah, in that way it will be, you can say that g is negative because g is downside, but this acceleration of this object, so it depends. If you are writing the acceleration of this 6g, so what will be the direction of acceleration? Downside, right? So with downside, g is the magnitude and downside. So now it is up to you, like you can give any direction. So if it is, you are saying that downside is the negative direction. So for this block, acceleration is minus g because downside is the negative direction. But for this block, acceleration is equal to g, positive g, because it is going upside and upside is positive direction. So magnitude is same, direction will be opposite. Okay. You understood this? So now you know that importance of equation of motion. How you can use, now you can use the equation of motion. Okay. So always remember that the left hand side is a force which provides the right hand side acceleration. That is the key concept. The F is equal to ma is not enough, right? In order to tell the formula it is enough, but in order to solve the problem it is not enough. In order to solve the problem, you also need to know what is the force and how, what is this force doing. This is accelerating that object. So this is the force on the object, and then that mass is of that object and acceleration is of that object. Okay. So this acceleration is due to the force in left hand side. That's very important. I will ask you this question in uniform circular motion. Okay. Okay. So this is about the second law and equation of motion and use of equation of motion. And we also understood the third law by N, mg, normal reaction, action and reaction, right? You can understand this action reaction by this way. If you say this is the object first, this is second. So you will write a force on first object due to the second object is equal to negative of force on second object due to first object. Good. So this is the, these are the Newton's three laws. But we didn't discuss the vectors and also, like we did discuss now vectors though. Yeah, did we? The vectors motion in 2D plane, didn't we? Okay. And we discussed the motion in 2D plane, or this is motion in the 2D plane, but about the vectors addition, we didn't discuss, right? That is also important, so we will consider that as well. Currently, we don't have time, so in the next class, first we will discuss the vectors, how to add vectors, okay, and how to subtract vectors, how to multiply the vectors, what will be the direction of the cross product, all these things, and then we will come to this fourth chapter and we will complete this. We will be going over the first part of this 11th only, the physics first, because that is going to be used in further physics classes. Okay. So if you have any doubt, any doubt? So what is your work? You are not doing work, right? The homework. Homework you are not doing, right? Yeah. Huh? The homework was like the revising first chapter and second chapter like that. Did you revise? Yeah. That is why you are able to calculate this numerical correctly, right? Okay. Then what you can do? You can revise. You revise the first chapter and second chapter, dimension and motion in 1D from the book, not from the notes, from the book. Because in the notes it is written very like, just definition is there, but meaning is not there. In the book, meaning is there. Any book like your textbook from the previous class, NCERT, right? NCERT. So how, like, it's not a pressure. How, like, you can, if you can revise one chapter, then revise one. If you can revise second chapter, you can revise two chapters. So at least revise these two chapters, dimensions and motion in 1D. After completing the vectors, you will be revising the third chapter also. Keep revising, just need to revise the first physics book, physics first from the previous class. Then we will start 12th physics. Got it? Any doubt in these concepts and all? Any doubt? If you did not understand, you can freely speak.